Okay, what's up, everybody? Unfortunately, this morning was a bit of a repeat of yesterday morning. So, yesterday morning, I was all ready to get started doing my live stream, and my trusty lavalier microphone appeared to kind of die. This morning, I tested it again, and it was working fine until I started streaming. Then it appeared to die again. So I'm not going to be using this microphone anymore. And unfortunately, again for today, the audio quality is going to be pretty terrible. If you're wondering what that fan noise is, my computer is quite close to the webcam, and I can neither move my webcam nor move the computer quickly and easily right now. So unfortunately, everyone will just have to bear with the audio quality. If it is too quiet or too loud, then do let me know and I'll try and fix it. But yeah, I'm going to be picking up a new microphone this week, that's for sure. Anyways, hopefully everyone's doing well though. So, as usual, we'll just get started. If you like what I do and would like to see me do it better, then please do consider supporting WiseAss on Google+, Facebook, Twitter, and we also have a Slack channel going on. Obviously, you're going to be watching this on YouTube, so please do consider subscribing if you haven't already. And hit the like button down below if you learned anything today. So, yeah, let's get started with today. Alright, so first things first, in this live coding episode, which is number 12, I'm actually going to do something a little bit different. So I've been working on the Catalyst application for, I believe, the past 11 episodes, and today I'm actually going to be doing something slightly different with another project that I'm going to be working on. I am almost hesitant to do this because the audio quality is so goddamn terrible with this webcam, but I'm going to try and do it anyway. And what I'm talking about is I'm going to try and discuss sort of the latest evolution of my architecture and how Kotlin has kind of affected it. Now, if you're wondering if I'm going to be answering a ton of questions about this, this is still live coding, but part of that process is me actually discussing and thinking about changes in architecture and things like that. So I'm going to spend some time talking about what I would like to do. I don't know exactly how much coding will get done today, but yeah, I just wanted to intro the show with some really interesting stuff that I've been learning and working on lately. And I'll spend some time later on to try and answer maybe a question or two, but once I'm done talking, I'll plan to just get right to coding. So, also I apologize if I look tired and grumpy. That's because I am very tired and very grumpy right now. It's, you know, been one of those weeks, so... but anyways, I will try to keep my baggage under control and we can get started. So, I'm going to be building an application called Space Notes, and I won't go into too much details about that, but the basic idea is I want to build an application which of course has a local and a remote data source and just demonstrates a whole bunch of things that I just want to sort of rebuild with sort of some newfound knowledge of Kotlin. So there's a couple different things which I've learned lately which have kind of really blown my mind. And what I'll be talking about is some of the challenges which I'll need to be dealing with these particular changes. So I've got a diagram in front of me. And so basically what this is this is I don't know how much I'll be implementing of this today, but this is what I plan on implementing quite quickly. So, as most of you know, or if any of you are, if you're familiar with my work, you know that I generally follow a style of architecture called Model View Presenter plus a View Model. I don't actually like to call it anything in particular anymore because I find a lot of these names actually kind of just detract from, you know, it just causes more confusion than anything else. What I'm showing you right here is just a small portion of the architecture, and let me just kind of explain why I did this, what it kind of means, and hopefully that will kind of give some input into how I actually go about reasoning my architectures. So one of the most important things, changes recently, is that, let me just pull up some code. So whereas I used to do, let's see, do I have Catalyst open? No. Whereas I used to have, so let me pull the classes up. So as most of you know, I'm a pretty big fan of clean architecture. And how I used to build clean architecture interactors, which are like a middleware class, is they used to be actual classes. They used to be classes that held the repositories they required, and I would work with them that way. Now, what I've seen sort of recently is that through Kotlin extension functions and coroutines, I can actually basically build those things without actually requiring an object to contain them, as you can see here. Again, this is a little tricky for me to manage. But as you can see here, if let me just pull up a interactor from Catalyst. Just give me one moment here. Oh, that's not what I wanted. Domain, there we go. Okay, so this is typically how I build interactors in the past, which would be to create a class, and then the class would contain the repositories, and then anytime presenter or whatever front-end decision maker class you choose to call it would ask this interactor to get some kind of data, whatever data it needs. So if it needs to get a workout from a database, it calls workout interactor get workout. And so these things would actually exist within the presenter's dependencies. So what I have recently seen is that we can actually do things a little bit differently in Kotlin, which is that we can actually just represent basically the same use cases. So you'll see here I have ignore this part for now, just ignore it. I'll talk about it in a minute maybe. But notice how we have get notes, or get note with an ID, and that we do have a local and a remote repository in this function. This is fundamentally the same idea as with the workout interactor class. Again, we have the repository. This one doesn't yet require a remote repository. And then we have get workout, which is almost identical. They're both suspending functions, and so this is basically how I was planning on building interactors as little as 2 weeks ago. What I've sort of been experimenting lately with is going a little bit more functional, and a big part of going functional is that in order to basically properly execute these use cases or interactors, for lack of a better term, the function needs to be given every object that it needs in order to carry out its operations. And since these are functions, as far as I'm aware, I'm probably not going to be using Dagger2 to, say, inject these dependencies into these functions, because I could be wrong, but I don't think Dagger2 is capable of injecting that way. I could be wrong, maybe there's an advanced feature that allows that, but to get to the point, I'm not actually concerned about using Dagger2 in this particular application anyways. So, with that little bit of a code preamble, we have a problem. So I want to be building these interactors as extension functions, as you can see here, extensions on Coroutine Scope. But I can't use dependency injection. Well, I can use dependency injection, excuse me, that's wrong. I can't use the @inject annotations to provide the dependencies. If I want these extension functions to be called by the presenter, which is what I'm demonstrating here, the presenter uses the interactor extensions, then obviously I might run into a situation where the presenter needs to actually contain the dependencies, so the repositories, whatever repositories I need. Now, that is very against what a presenter should be responsible for doing. So what I've actually figured or decided to do is partly through usage of an abstract class, I'm actually going to be having all of my presenters inherit from an abstract presenter. And this abstract presenter is going to do a couple things, but one of the main things I'm going to try, and I haven't implemented this yet, is I'm going to try and set it up with what I am tentatively labeling a service locator, although I'm not, what I have in my head might be different from the typical implementation of a service locator, but that's just the best name I could think of to find it. And what this service locator's job will be is to actually sort of hide these repositories from the specific presenter implementations. So in essence, I don't want any presenter that I write to basically be aware of this service locator any more than it needs to be. And what I'll try to do is this service locator will actually hold whatever services I need. It doesn't have to be a repository. It could be a system service. It could be a REST adapter. It could be whatever. It's going to hold on to those. Now, there are going to be challenges in doing this, because one of the things I got to be really careful about is if I don't build this service locator object properly, then it's going to have potentially a huge memory footprint. It's potentially going to be holding reference to a lot of fairly large objects, and I need to be really careful about that. So with that in mind, and there, I'm going to look into different ways. I'm considering using the lazy loading delegates in Kotlin if they prove to work properly, or not properly, but the way I think they work. I just need to do a bit more research into that. But the main thing I'm going to be concerned about is if you're going to have some big-ass class that holds a whole bunch of dependencies, and probably this thing will also hold context, then I just want to be really careful about the memory footprint that it creates. And just in case people are watching and curious, since I do have a couple people here, if you're wondering about what these different arrows mean, a dotted line with an arrow is UML, Unified Modeling Language. For uses, so just a dependency, this hollow triangle with an arrow, this line with a hollow triangle, represents inheritance, so presenter inherits from base presenter. That's another uses sign here, so the presenter will use my interactor extensions. The interactor extensions will use the presenters. And this one here means that this object it holds the repository objects. So that's basically the gist of this little diagram here. So with that, I'm going to start we're going to start today by working on this base presenter. And then I'll possibly get into the service locator, but we'll see about that because I haven't actually built a lot of the rest of this particular application. I won't be putting the code for this application up immediately. It might be a couple weeks before I do. So unfortunately, if you do want to follow along, you have to understand that I'm actually like building this on the fly, and I'm not actually 100% sure what it's going to look like in the end. So I'm not going to go posting a whole bunch of code online that might lead people down the wrong path. So once I'm more confident that this particular application is built well and doesn't have any memory leaks, then I will absolutely put it open source. But for now, if you're kind of wondering, it's not going to happen. Alrighty. So just to address the chat for a moment. So I've got a question from Honey, and Honey asks something about Room database. So this isn't actually the live stream Q&A, and the Q&A episodes happen on the Sundays. So I may be able to help you next week, but for now this is actually just live coding. So it's not that I don't ever answer questions, but please, if you have questions outside of what I'll be doing today, then please do stop by on the Sunday Q&A and I can try and help you. So let's get started with the coding. Thank you for your patience. Okay, so first things first, what I need to do is, so I'm in the app module and I have this package called common, and then I have a presenter already partly implemented. So for those who are wondering, Kotlin also has abstract classes, the same as Java does, and they are quite similar, both of them. When you would want to use an abstract class versus an interface is mainly if you have some implementation and some method stubs that you would like to include, whereas an interface, as far as Kotlin is concerned, I don't think there's any way for an interface to contain implementation. Maybe there's like some, I can't remember if Kotlin has default methods, but yes, just suffice it to say that I do believe an abstract class will be most useful here, and I'm going to try and build it out the best I can. Alright. And this is where things get tricky. I will do my best to monitor the chat, but I have code windows open on the side to help me along here, so I'll have to kind of check in and out with questions that people have. Okay, and am I on the wrong catalyst? Okay, just give me a moment. I need to open Catalyst in Android Studio. That was kind of silly that I didn't do that earlier. Okay. Alright. Just going to be a bit of downtime while I get everything pulled together here. Great, so first things first, let's consider what I want in this presenter base class. So, I'm not necessarily, yeah, what I'll do, oh, this is the wrong branch for that one. Okay, so the main thing I'm going to want to do is I want my base presenter class to extend Coroutine Scope. Can I do that with abstract classes? Yes. And so this is actually how we are going to make these interactors work. So notice how they are an extension function of Coroutine Scope. I'm going to make sure that every presenter implements Coroutine Scope. And what that's going to allow is it's going to give us a situation like we have here in Kotlin MVP Calculator, which is where the presenter essentially acts as like the how can I phrase it, the root of the structured coroutine operations. It's very hard to put into simple language, but this is basically what I would like every presenter to have, is this bunch of code here, along with, say, a bind and a clear function as well, which I have here. And I think I can actually implement those in the abstract class. I'm told that I slightly screwed up my Patreon link, so thanks for the heads up on that. I will check into that. Alright, so let's get started implementing these particular functions here. So the nice thing about, as I say, the nice thing about abstract classes is you can leave functions unimplemented if you want the inheriting class to implement them, but you should also be able to include functions which do actually have the implementation. But what I'll need to do is I'll need to first create the, let's see here, the appropriate properties. So, and again, I'm getting used to abstract classes in Kotlin, so we'll see how this goes. So I want one called job tracker. Okay, so if you wonder what job is, when you fire a launch coroutine, it actually optionally returns a job object, like so. This is valid. And so what you can do is when you launch a coroutine, so launch is a coroutine builder, and it's like a fire and forget kind of coroutine. You can optionally return this job object. Sometimes you don't want to bother, so I don't need to bother with it in the context of this suspending function, which is itself its own coroutine context, essentially. But in this case, with a presenter, I do want to be able to cancel the current jobs that are being executed. The cool thing about coroutines and making basically your presenter as like the end of the event stream, which is usually the case if you're familiar with RxJava, you'd usually do it that way as well, is that if I cancel this job tracker, then all of my downstream coroutines and backend operations will also automatically be dismantled. So what that basically means is, let's say I call get notes to the interactor from the presenter. If that backend operation is going on, let's say it's checking a local and a remote data source, which will be what this application does eventually, then how that basically works is, let's say the user rotates or just navigates away from this particular feature of the application. All I need to do is in the clear function of the presenter, which we'll code in a moment, I just need to cancel the job, this root job object here, and that will cancel all the downstream coroutines and events. So this, like I say, this is very similar to the pattern you would see in RxJava, and that's basically what I'm basing it off of. So we're also going to add, I'm curious as to why it isn't forcing me to add this coroutine context. We'll see, because I thought it was doing that before. So we're going to say override val coroutine, how do I spell that? Coroutine context. Okay. And then we're going to provide a getter for it. So if you're not familiar with properties in Kotlin, you don't need to provide getters and setters if you just need the basic form of a getter and setter, set this value or get this value. But if you want a customized getter or setter, then all you need to do is you can just say either get, you can call this little get function here and then supply, well, we'll see what it does in a moment. And you can also optionally say set. And these are both basically to implement the getters and setters if you need to override them in Kotlin. It's a nice little feature. So one of the things I'm figuring out already is this thing is going to need a dispatcher, our base presenter. And I'm also going to rename this to base presenter just to make it a little less ambiguous. And I don't think I want to rename those, no. Yes, there we go. And okay, so I've got that going. Let's add in a dispatcher here. Oops. So we're going to say private val dispatcher, which is going to be of type coroutine. Maybe I won't do I want to do it that way? It's not actually that type. So this is a custom class that I created. So we're going to call this thing dispatcher provider. I'm going to create it. Let's build it in... I'll build it in common. I think that's the most sensible place to put it. So we'll call this thing dispatcher provider. And I believe what we'll do is we'll make an interface. So this one will actually be, let me just fix this up. So we're going to call this iDispatcher provider. I just want to make it an, do I need to make it an interface? I could use a mock instead. I don't expect to be swapping the implementation out. Ah, fuck it, I'm not going to bother making an interface, fuck it. Okay, so class dispatcher provider, and let's see what that looks like in the other project. How's everyone doing today, by the way? I apologize, I'm obviously not a very high energy individual today, but I hope I'm not dragging anybody down, and hopefully your projects are going well. Okay, so dispatcher provider, where are you? You're here. Great. Oh, whoops. I'm literally just copying and pasting from Kotlin MVP calculator parts of this stuff. Because there's no point. Why does it keep doing that? Can I get copy and paste to work here? There we go. Sweet. Great. Okay. So, dispatchers. It looks like I might need to add... Yes, I want you to... stupid friggin' ID. Okay, so it looks like I probably need to add a dependency to build Gradle, so I'm going to go Control Shift N, build.gradle. And let me see what particular dependency I'm missing. Oh, I got to make sure I open up the correct build.gradle, of course. And let me just see which particular library I am missing. Okay. So I've got all my extensions. What else do we have? Huh. Not exactly sure what I'm missing here. Alright, I'm just going to make sure that my dependencies are correct. So, why is that not working? There we go. So what I'm trying to do is I need this dispatcher's class. I should have it. Do I seriously need to do this? Is that... Like, why is that? It must be the wrong version of Gradle, or Kotlin, or Coroutines, or whatever. That's bizarre. Okay. Kotlin... What are my versions? Okay, so Coroutines is 0.30.2, so that's definitely fine. Kotlin is 1.2.70. So what exactly is the problem? If you're wondering what I'm trying to figure out here, I'm actually just trying to... Kotlin X, is that the problem? Do I not have Kotlin extensions in build.gradle? I'm just trying to get a bloody class to import, so we're not actually solving any major problems here. No, I've got Android extensions. That is very bizarre. Well, I'm going to look at the chat really briefly, because oftentimes someone else has suggested a solution and doesn't look like it. That's very strange. I don't I was pretty confident that dispatcher provider is included in that library, so that's really kind of just blowing me away. I'm just going to clean the project and see if that fixes it. That's really weird. Very strange. Okay, there we... Oh. How are we doing? Still doesn't want to import it. God, that's bizarre. Ah, well. Let me just check dependencies from Kotlin MVP calculator. Maybe I missed one. I might be looking... I believe Catalyst uses this pattern, doesn't it? Or have I not actually... Okay, I haven't actually implemented it, so maybe the problem is I am looking at the wrong... I'm trying to compare it to the wrong Gradle file, so that could actually be the issue. Oh, it's probably Coroutine's Android. That's almost definitely what it is. I don't think I have that here, do I? Space notes. No, I do have Coroutine's Android. What the fuck? Sorry, there's going to be a lot of swearing today. That is so bizarre. Well, you know what, I'm not actually going to, here's what we're going to do, since I don't really want to piss around with this all day. I am actually just going to make this an interface. I don't care what it returns at this particular point, other than coroutine context, which is fine. And we're actually just going to, instead of just commenting it out, we're going to say return to do. And so that'll get rid of our compiler warning, and everything is wonderful. Let's just get rid of this stupid import altogether. Actually, I'm just going to try... what the hell? Okay. Okay. Sorry, just one last attempt at fiddling around here. I can't help myself. Okay, util. Yeah, it's so bloody weird. Okay, experimental. What if I did this? Dispatchers. Nope, okay, screw it. That's okay. I'll figure it out later. It's not a big deal. So we're going to make this of type... I'm just going to rename this to make sure I'm following my naming conventions, iDispatcher provider. And then we'll supply iDispatcher provider. And that's one of the benefits of using interfaces, is that you can basically defer decisions like that. And now it's going to be bugging me that it can't see that iDispatcher provider. And that's pretty odd as well. Man, we're off to a great start today. This is unreal. Huh. I'm very lucky. I guess that's what it is. Why would that now not be importing? This is just incredible. Common. I don't know what's going on with my friggin' IDE this morning. Like, I can't perform basic imports, so I'm just kind of gobsmacked here. Like, this is absolutely incredible. Oh, so this is the first issue. So these are interfaces, and they shouldn't have any implementation. So that's my first bloody issue. That's so bizarre. Interface. How am I writing this incorrectly? Oh, this is live coding for you. It can suck. Yeah. Okay. So get. Oh, what a day. I'm reminded of an episode I had a couple weeks ago where everything was going wrong. Not everything, but some things were going wrong, and a fellow who just recently got a job, my friend Victor, was commenting that he was kind of happy to see someone else kind of struggling with their IDE and coding. And, you know, to be honest, this is actually, you know, no matter how good I get at coding, you always tend to run into issues like this. So anyways, let's try to just keep on track here and keep going. So base presenter. So let's reopen this presenter class. That's so bizarre though. I can't perform basic imports. Like, when does that ever even happen? And the project's building. So, very bizarre. Okay. I can't even write my code if I can't import this thing. Okay, can people in the, I'm gonna look at the chat here, like, does it, no package interface file? Oh, because it doesn't have the, oh, okay, that's probably what it was, thank you. That was the issue, you know. You know, God forbid I get some kind of warning from my IDE, or my IDE decides to import that for me. Okay, great, we're back on track. Thank you, Wolf. Oh, that was a headache. Okay, great. So let's get back to what we were doing before. And so all I'm going to do is we're going to implement these functions here. So I don't, yeah, they don't need to be abstract because I'll actually be implementing them. Oh, that was a lovely detour. Okay, and what do they say? So in this particular case, what do I do? So clear. So what I'm going to do is I'm going to have this bind method say job tracker equals job. So this is when a presenter first gets created. The view in its onResume method, the fragment, which is a view, is going to actually say to the presenter bind, and that's really the only direction that my presenters take from any class, is pretty much when to bind. And then once I want to clear the, or dispose of the background work, then in clear I'm going to say job tracker.cancel. And this is just like you would see in sort of like an RxJava implementation. Now I also will be, I'm going to want an abstract function here. And that's going to be bind view models, or let's just say bind view model. And actually I don't want to implement that. Yeah, and okay, so that's basically it. And what else have we got here? Is there anything else? I do want this thing to, yeah, I'll need lifecycle observer. So I actually want my base presenters to be lifecycle observers. Let me just double check if I imported that in the build Gradle. I got lifecycle. Which one is it? Lifecycle. I need the Arch lifecycle import. Okay, it might work. We'll see. I'm not entirely sure where this class comes from, but we'll see in a moment. Let's just give it a shot. So do I have access to, which one am I looking at? Observer? Okay, I do. Sweet. That's what I want. clean this up a little bit. And what kind of observer do I want it to be? So it's going to be observing what? It observes... You know, I don't actually... I'm waffling on something. So this is how I implemented it in the other project, but I'm not actually sure if I want to do that exactly the same way. Let's just keep the Coroutine Scope for now. That's fine. I've got the job tracker. That's what I want. I've basically got this more or less where I need it. The only thing I also need to add is the service locator. So let's just call that locator. And let's see, service locator. Hopefully that's right. I can't remember if that's how you spell locator. That is how you spell locator. Great. Okay. And I'm going to create that in Common as well. So this is where things are going to get interesting. So I probably want this to be... No, I don't think I want it to be an object. So as I mentioned before, this is where things are going to get interesting, because this service locator class, if I build it poorly, then I'm basically setting myself up for a memory disaster. So we'll just have to kind of see how that goes. I know it's going to need context. Context, Android context is fine. And so what this thing is going to be full of, it's going to be full of methods to provide my repository classes, which sit in... The interfaces for my repositories will be in my domain layer here, under repository. And then the implementations of those repositories will be in the data... Sorry, I said layer, domain layer. I meant domain module. You could think of it like a layer. And then the implementations of the repositories will be in the data module. And that's a little pattern I learned from my friend Dependencies, which works really, really nicely. So what I'll do is, just to demonstrate the idea of what I'm doing, I'll just kind of show you what this thing will eventually do. It's going to have a bunch of methods like fun, provide, local repository, and that's going to return a the repository. What is it called? A note repository. And then I'm going to, of course, have the provide remote repository. And so when I call when I call the extension interactors, for lack of a better term, where they're going to get the repositories from is this service locator object. But I want to try and do this in a way that my presenters know as little about that stuff as possible, because the job of the presenter class, essentially, the way I like to think of presenters, is that they're front-end decision makers. So they don't hold state, they don't create things, they can manipulate objects as they come in and out from different sources, but their main job is to coordinate. The view says this, so let's send this message to the data layer. The data layer responds with some response, and then we choose to somehow render that in the view. And that's essentially how I view presenters, a front-end decision maker. Now, I will also have a view model, but I'm not going to fill a view model with logic, because in my opinion, I don't like to do that. I think if you're going to fill something called a view model with logic, then you probably should name it something other than a view model, which implies two things that don't have any logic in them. But yeah, anyways, that's just my personal rant on that particular name. But I like the model view model pattern insofar as it can be Understood. All right. So, yeah. So, we're about 10 minutes, or even just 5 minutes to 11, so I'm just going to open up for some questions about what I was doing today, and I'll stick around for a couple minutes, and then we will call it a day. I do apologize, I realize it probably wasn't a great episode, but hopefully, and even just talking about this stuff, it's interesting to some of you people. And later in the week, or next week, I should have a lot more stuff to talk about, and I should be further along in constructing my setup here. So yeah, with that, I will run a quick commercial break, and like I say, if you have any questions, now is the time to ask. Hopefully the question is about what I was doing today, but I can try and answer other questions. Okay, so this is, this is just how my day is going. I have monetization enabled in YouTube, but I can't click the create ad button or the play ad button. So I won't be running a commercial break because YouTube doesn't want me to, apparently. So that's totally fine. I'll still stick around and run some questions, or answer some questions if you have any. But man, what a day! All right, we got like 30 seconds. Anyways, I'm going to be picking up a new microphone very shortly, and hopefully our live streams will be just a little bit more functional next week. Okay, so no more questions. So thank you so much for watching, and hopefully we'll see you next week for the live stream Q&A. And I'm hoping that the next live coding episode will be a lot better than today's episode. So that's basically it. Thank you for watching, and peace out.